Okay. Right, I think we can make a start. People can drop in as they have the time and remember to join us. As you know, this is live on Zoom and also live streamed over on YouTube. For those of you watching, 12 people on YouTube right now. For those of you watching us over there, welcome to the CNS talk, and feel free to write your questions over on YouTube, and I will then bring the questions over here and relay them to Lauren, who will ask our lovely speaker later on. Today, it's my great pleasure to welcome Alfredo Spagna as our speaker for the CNS talk. He has a PhD in cognitive neuroscience from the Department of Cognitive Psychology in Sapienza, the University of Rome, and is currently a lecturer at Columbia University for psychology. And he's very interested in the neurobasis of attention and cognitive control. Sorry, I just got distracted. The team is texting over here. Right. Sorry about that. Without further ado, welcome. Thank you so much for being here and giving a talk for us today. Live applause. And I hand over to you. Take it away.
Thank you so much for having me. Welcome, everyone. I'm going to start sharing my screen and you'll let me know if it's clear. Can you see this? How does it look?
Perfect.
It's good. All right, let me just open up this window over here so I can see you all. All right. Okay, so thank you so much for having me. Today, I'm going to talk, I want to discuss with you a little bit about visual mental imagery. With this talk that is called Visual Mental Imagery, What It Takes to Imagine Something. And it's not going to be a talk that is going to give you the truth about what it takes to imagine something. It's going to be a talk in which I really want to just drop a little bit of a few ideas about how mental imagery might work, and therefore also discuss with you towards the end the implications of studying mental imagery. So thanks again, CN Seminar for having me, and this work is being done both at Columbia and at ICM in Paris, where I worked with Paolo a few years ago, and we keep developing fantastic ideas, his fantastic ideas, especially. And here just a few plugs in case you want to check out more of my work. All right, so let's get this started with a list of topics. I'm going to discuss only 3 simple things. The first thing are issues with the dominant model of mental imagery. Very likely you have a textbook of cognitive neuroscience at home, and you have read about the main model of mental imagery, which has some issues, and some authors have been fairly vocal about the issues with this model, but still stands, and somehow my work also goes in the direction of trying to revise it. The second thing is I want to give you a quick look at a couple of our studies, and then we're going to propose a new model of mental imagery. In particular, we're going to do the simplistic or the simplification, or we're going to have a reductionistic approach. And when we say mental imagery, for the sake of time, we will say visual mental imagery, or we focus a lot on visual mental imagery here. But of course, the literature on auditory mental imagery exists, motor mental imagery exists, olfactory and olfactory mental imagery also exists, and so on. But first, as always, I'm going to ask you to do a little bit of an exercise with me. So I'm going to ask you to please close your eyes, and I can see you. So close your eyes, I can see you. And now think about Valentina, I can see you. Okay, and now think about Leonardo da Vinci's Mona Lisa, and keep your eyes closed. So try to visualize in your mind Mona Lisa, and keep your eyes closed and think if she's looking at you or not. You don't have to answer now. Keep your eyes closed. And then think whether her hair is curled or straight. And now you can open your eyes, and there she is. There's Mona Lisa, and you can then fairly quickly compare, what your decision was about she looking at you or not with what the actual perception of Mona Lisa is. So I'm gonna call on Leah. You just have a question for you. Was she looking at you or not?
Yes, she was looking at me.
Okay, nice. And Victor, hair curl or straight?
Straight for me.
All right, nice. So thank you so much for participating in this experiment, which it's there just to make you think about one thing. We struggled so much with, in the history of cognitive psychology, experimental psychology, cognitive neuroscience, and so on, and really presenting the stimuli with a very timed manner. But it's so simple to study mental imagery on one side, right? It didn't take me anything. It takes just an instruction and your brain. I don't need a monitor. I don't need a mouse. I don't need a keyboard. I don't need to record. So it's very strange. What I'm trying to say is that it's very strange that mental imagery is so behind other fields, while in reality it could be prompted fairly easily, like we just did. So now I'm going to ask you to tell me about your subjective experience of imagining Mona Lisa. And Valentina, this is for you. So what happened when I asked you to imagine Mona Lisa?
So I didn't have all the particulars of the details of the painting that you asked ready, and they started to appear as you were speaking of it.
Fantastic. So somehow, if I think about, thank you so much, Valentina. If I think about my subjective experience of mental imagery, it looks a little bit like what Cecilia Jimenez did to the attempt of restoring the Ecce Homo, just reusing some clinic products. So my mental imagery looks like this, but in reality, the painting before this fantastic restoring attempt with Windex and Clorox was more like this, and the expectation was that it was going to be like this. So somehow what Valentina just mentioned is true for the great majority of us. Mental images are never as crisp as we would like them to be sometimes, or are never as crisp as the perception. They are blurrier. Some details are not there. So if I can break it down in more of a theoretical way, I think more from going from the subjective side to more of a theoretical or objective way, I think that to imagine something, I need to have the image in my long-term memory somewhere. I'm asking you about Mona Lisa. If you've never seen Mona Lisa, you will never know what to imagine, right? So the information of Mona Lisa must be stored in LTM somewhere. And as we said, the image is not as crisp as the seeing Mona Lisa. It's like blurred. But wait a minute, there is one thing about this that is very important. What we are saying is that it's not that you cannot imagine something that it's new, meaning you can imagine a dog telephone. You can synthesize between items that are already in long-term memory to create a new mental image. What you cannot do is to imagine a dog telephone if you have never seen a dog or a telephone. So we're not stripping mental imagery from its creative side, but somehow the smallest component must be somewhere in long-term memory. But a second part that also Valentina mentioned before is somehow when you imagine an apple, you imagine the apple and then details start popping up, right? Because we need somehow a mechanism for maintaining, sustaining this mental image, Mona Lisa, and then do what Victor did, which is, okay, hair curled or straight. You zoom in into the hair and you try to get a sense of curled or straight. So somehow we need a mechanism to say eyes looking at me or not, hands, hair, and so on. So we need something that helps you maintain over time this image. Mental images can be very volatile if we don't sustain them. The third mechanism, or the third component, or that we just had to implement in this task because I was asking you something, is decision making. So pressing a button or unmuting yourself to saying if Mona Lisa is looking at you or not, or her hair is curled or straight. So somehow we have played with these three different components. So what are the issues with the dominant model of mental imagery? Well, if you have read a cognitive neuroscience textbook already, which I'm sure you have, the strongest idea about how mental imagery works is that somehow mental imagery relies on the activation of early visual cortex areas to the point of V1, downward in the string into V1. And this had, in early 2000, a fairly good amount of evidence supporting it. PET studies, FMRI studies, down to TMS studies showing that if you interfere with the activity in V1, you can disrupt the ability to produce mental images. So somehow this is what the dominant model, one of the main claims of the dominant model of mental imagery. You need the same structures that you need for perception, you need them in mental imagery. A very simplistic and somehow effective view to describe mental images. However, for some reasons, I wasn't there, so I cannot take responsibility for it, but for some reasons, over the years, this model has been resistant to a gigantic number of evidence against it, which actually preceded sometimes the actual model, starting from Mark Desposito first fMRI studies. And I mean, if you say something, if you say Desposito and fMRI, you're right. So here, what it looks like in this early fMRI study is that somehow mental imagery required more inferior temporal, medial temporal areas rather than occipital activation. There is actually no occipital activation in this diagram at all. Another study from Marta Berardinelli, who was my professor of general psychology many years ago, was again, look at visual imagery, auditory imagery, tactile imagery, and so on. And they didn't observe that much occipital activation. What this is, again, this more anterior areas, mostly in the inferior temporal lobe, activated supramodally, meaning irrespective of sensory modality. Then another article from 2006 from Sodu, in which, again, they did all these imagery tasks, including counting down, imagine to prepare a language, imagine walking from home to work, describing a face, imagine filling a check, describing your own thoughts, and you don't see V1 at all. You are very far away from V1, V2. Anything that you see in this list of occipital, whatever it's occipital is parietal occipital, so much more dorsal, or occipital temporal gyrus, so much more inferior and further away from what V1 is. Very interesting, this study actually from Sodu, they were able to identify that they had a group of patients with disorder of consciousness. So check it out, it's a very interesting article. But we can keep going, and if you were thinking that I was showing you only old stuff, 2014 article, 2019 articles, they keep showing that there is no early visual activation associated with mental imagery. And I can keep going. And this is getting tedious, so I'll stop here. But again, imagery versus baseline, imagery versus rest, we see this stuff. You don't see this stuff. You don't see anything in the green. There is no occipital activation. So this is, again, another fMRI study. Actually, in a study that compared visual imaging versus baseline in 2013, and this is not the only evidence of this, actually, the visual areas show a reduced activity when you're imagining something compared to baseline. So actually, while in yellow, we see the areas that show, and again, look at this inferior temporal blob in the left side, especially, while we observe that some areas here depicted in yellow showed enhanced activation compared to baseline, actually, the primary visual and also a little bit of primary auditory cortex showed reduced activation compared to baseline. Actually, Giorgio Ganis from Harvard in 2004 told you that visual mental imaging and perception produce opposite adaptation effects. To Nadine Ditra, and check her out, her work, she's doing incredible things. Studying on mental imagery, actually show differential temporal dynamics in visual imagery and perception. So the point is, how can we revise the old mental imagery model, but still think about this? This is a review article, Nature Review Neuroscience article published just a couple of years ago now, in which Pearson, who also is doing great work on mental imagery, still postulates, coming from this Coslin model of mental imagery, that somehow mental imagery requires the activation of this chunk of gray matter over here. Actually, what they are particularly vocal about is that while perception starts from a bottom-up and goes to a high-level brain areas, mental imagery somehow has a reversed hierarchy, follows a reverse hierarchy. So starts from top-down imagery signal of high-level brain areas, because of course I'm telling Leah, close your eyes and do something. So this is prefrontal, and then it goes down, and according to this model, Leah activates her own V1 to imagine Mona Lisa, while perception is, of course, V1, actually retina up to chiasm radiation, V1 and up to the ventral stream. So this is a revised version of the dominant model that proposes this reversed hierarchy, perception bottom up to the frontal lobe, and in imagery from the frontal lobe down to the B1, to the occipital cortex. So, however, and yet again, a fairly good number of authors have been very vocal about issues with this model, including the fact that individuals with no occipital cortex, for whichever reason, bilateral resection because of tumor and so on, they do show a deficit in perception, but not in imagery. So if you lose your occipital lobe, you won't perceive things, but you will still be able to imagine things. So is it possible that a lesion to a brain region considered necessary for a cognitive function does not produce any deficit? And the guy, Paul Broca, shows up. And says, are you serious? This is where we started. You have a lesion to a brain region that is necessary to a function, and you will lose some sort or up to a certain extent, that function. So the guy is staring at us thinking, you serious here? So just to lighten up this full frontal against the classical model, I'm going to tell you a few things also about non-human animals. For example, pigeons do it better, meaning pigeons do not show increasing reaction time at increasing angular disparities in a Shepard and Metzler kind of task. So we may think that mental imagery is a very high-level cognitive function, one of the most special, but actually pigeons are much better, or they don't show the slowing down in reaction time when performing a mental rotation task, like humans do. But chimpanzees do it better than gorillas. Because, for example, again, visual spatial ability of chimpanzees seems to be better than other, the orangutan and gorilla, but not the bonobo. And this, again, this is work reviewed by Laura Tremblay in an upcoming article. And then I'm going to pause here 1 second, and I'm going to ask you to guess what these 3 lines are. Don't spoil my slide. So the task that we're doing is kind of a visual spatial imagery task. So what do you think these 3 lines are? What do we have in red? What do we have in blue? And what do we have in yellow? Peter, what do you think we have in red?
Well, I'm
Who is this group of people that is performing so well with 100% correct in this visual spatial task?
What is the group of people?
Right, what is this category? What's going on here?
Well, I don't know. I guess that wasn't even going to be my answer, because since we're talking about non-human animals, I was suspecting this was a comparison between humans and chimpanzees and perhaps dogs or something like that. So,
okay, so I'm gonna tell you that one of these 3 lines is healthy adults. So we are comparing with actually humans, right? Stephanie, who do you think is the red, blue, or yellow? Give me a shot. Try it.
So one of them is humans.
One of them is adult humans, correct?
Well, let's assume that they're the worst. So the yellow line.
Okay. And how about the blue?
Do we already know the other options? Sorry, I was distracted with the social media.
Don't worry.
Was it non-human?
Okay, I'm gonna spoil it to you. But thank you for playing with me about this a second. The red line is a gray parrot. The gray parrot performs better than human. A gray parrot, singular, sorry, performs better than humans in a set size of 3 in a task of visual spatial, working memory, remember where things are, imagine where things should be later on. Better than adults, and especially better than children, 6 to 8 years old. So again, we are maybe overcomplicating this mental imagery ability, or we're maybe taking it from a completely incorrect angle. So parrots have greater visual spatial imagery compared to a 6 to 8 years old kid. And I'm gonna take a second of a break here. And do you have any question up until what we just discussed? Are we good? Everything is clear? Get ready. Okay, so I'm going to move from the issues with the mental imagery stuff to a couple of our studies. To recap, what we just saw is we have a model, pretty influential, we loved it. It helped us study imagery in the past years. It has a problem or multiple problems. One specifically, visual mental imagery does not rely on early visual cortex, apparently. So So working with Paolo, again, as Stephanie mentioned at the beginning of this introduction, I was studying attention and cognitive control, and then I started working with Paolo, and he told me about this idea of mental imagery, and I was like, I don't know anything about it. So I'm going to do a review of the literature because I want to read about it. So we came up just this year with this very huge meta-analysis of the literature, which is one of those papers that looks like this, and you don't really want to read it. I mean, I hope you read it, but you don't want to read it because it's tables and tables forever. So I'm going to just summarize it for you right now. So what we did is we went into Google Scholar, PubMed, Neurosync, and so on. We tried to pull up all the articles that showed that had mental imagery, visual mental imagery, and so on in the visual spatial and so on in the article. And we came up ultimately with a fairly low number of studies, 84 plus 39. Some of them were actually double, meaning we found them in both Google Scholar and Neurosync. So we had to skim down with exclusion criteria, meaning we didn't want single subject studies, no PT study, no clinical groups. Then we kept on excluding more based on they are not reporting coordinates of interest for our study. Then some of them were about machine learning, MVPA, only connectivity analysis, and so on. So skimming down from these 120 something articles down to what was really usable for our scope, we came up with a literature that has 27 good studies having a fairly reasonable mental imagery versus control condition, 4 that have a mental imagery versus perception condition, and 15 motor imagery versus control condition. So if I just get the coordinates from the table, it was a tedious work. Never do a meta-analysis unless you really have to. If you just go into each one of these articles and you pull line by line from the only table you are interested in, and you pull all the coordinates and you put into your Excel sheet and you plot them on a surface, this is what it looks like the image on the right. Coordinates, meaning activation foci, were located everywhere. You don't see a clear pattern telling you for sure visual mental imagery is occipital. Look, you see a lot of visual mental imagery in the occipital lobe and not so much anywhere else. That is not the case. So we did we used ginger ale to do this meta-analysis. Somehow we just statistically observed the overlap of all the results from these 27 studies. And the first important result is that if you remember Mark Desposito 1997 article I showed you, Marta Berardinelli, and all the articles that I showed you, there was something going on in the left inferior temporal lobe. And this is what we found as well. Not surprising, somehow we are actually averaging Berardinelli, Desposito, and all those articles. So it's not surprising that we find that same spot. But the most consistent result, the strongest ginger ale stat, was this left inferior temporal gyrus, fusiform gyrus, hotspot. Which very interestingly, in a cytoarchitectonical studies done by Lawrence in 2017, seem to overlap our hotspot, seem to overlap with a specific part of their fusiform gyrus, which you can see in the bottom left part of this figure, being in between this FG4 and FG2 parts. So again, fusiform gyrus can be split down into multiple parts, 4 different parts. Now our hotspots seem to be crossing the bridge between FG2 and FG4. This is just for those very interested in cytoarchitecture. But also, our hotspot seemed to be surprisingly overlapping with an article that was published while we were doing this work. The famous case of the architect who lost the ability to imagine. This is a 2020 article from Thorudottir, a group in Finland, which compared in red, you can see at the bottom, the lesion of an architect that had that lost the ability to imagine, a person that at 50, until the day before the lesion, was able to imagine and visualize things in his mind to build a building, right, or design a room, and suddenly wasn't able anymore to do so, but by using the computer. So you had to use perception rather than imagery. And you can see that there is this tongue, this L-shaped kind of figure over here. Again, inferior temporal region on the left hemisphere, that somehow at least partially overlaps with our hotspot, with the hotspot that we find in our study. So again, you have a lesion, again, Broca comes back, you have a lesion to this area, you lose the ability to imagine, you do an fMRI study or 27 fMRI study, and this is the area that shows up, the fusiform gyrus. In the 2021 article, which is this year, by the way, we call this the Fusiform Imagery Node, the FIN. Another thing that we were very interested in observing in this article was there any evidence for early visual cortex activation? And no, I'm sorry. You do a meta-analysis of all the studies that you find out, and there's nothing going on in this part of the brain. And that was me thinking, okay, good. But then, of course, we know we cannot interpret null result with the common frequentist approaches. So we did a Bayesian meta-analysis, thanks to Montagna and Thorudottir's group, that actually created a way of running Bayesian statistics on meta-analysis coordinates. And again, the area colored in purple, the darker the color, the more absolutely nothing there is, so down to a BF value of 0. And then if you move in the white area, you have still a BF value that is extremely low. So using a spatial Bayesian latent factor regression for coordinate-based meta-analysis, which means Bayesian on meta-analysis, we found no visual cortex activation, reconciling what we knew from Marine Berman article in 1994, lesion to visual cortex, no deficit in imagery. And that was me. We found it. Let's move on. We got this. And then, of course, the guy came back and said, I told you. Why did you even bother doing this analysis? Okay. The third thing that I found out in this article, and that we found out in this article, is an old friend. I told you they started working with Paolo from the attention cognitive control area, right? And suddenly, one of the results of the meta-analysis was this friend that I already knew about. Frontal eye fields, bilateral, inferior parietal sulcus, bilateral, anterior insular cortex, bilateral, ACC, bilateral. And I saw it and I said, oh, but this is my friend. This is my buddy. I just worked on this 10 years ago. These are the frontoparietal and cingulopercular network. This is attention, working memory related stuff. I mean, we can go back to Corbetta, we can go back to Nico Dosenbach work, but we can also go back to an article we published a few years ago. This is a attention, working memory sustaining images, a network associated with visual mental imagery. I'm going to take a second break here. Second break. I'm going to take a sip of water. And if you have any questions, this is the right moment to ask it. You good? Okay. So what is the recap of what I just told you? If you look at seriously look at the meta-analysis, if you seriously look at the literature on mental imagery, and you do a meta-analysis, you observe 3 substantial results. A node in the left inferior temporal lobe, which is what I'm showing you in these regions. 2, no early visual cortex activation. 3, frontoparietal network, occipital, the singulopercular network, sustaining information. Then the next question that Paolo, Zhang-Hao, you and myself had was, but wait a minute, why only left fusiform gyrus? Why are you lateralizing this stuff? So we just published this new article in which we observed hemispheric asymmetry in visual mental imagery. Again, trying to go deeper and reconciling neuropsychological literature with neurostimulation literature from Penfield to the actual neuroimaging stuff. And this is what we observed. Top row, category that seems to be categories of visual mental imagery that seem to be more left lateralized. For example, if I ask you to sing a song, so Stephanie, mentally sing in your mind, happy birthday, no, not sing, just mentally think about happy birthday. Okay, you will see left inferior temporal lobe area, not really right. I'm gonna point at it, right? But if instead I ask you to imagine a face, well, you see slightly more right than left. So somehow maybe we observed only left fin in our studies because our studies were more biased towards naming objects, naming colors. Why? Because mental imagery tasks are very much about close your eyes and think about a hammer. When you imagine hammer, press. So that's a word instruction, hammer, beaver, fox, spoon. So I'm using words to prompt your mental imagery, and therefore it's very likely that we see a left lateralized activation. But this is not supposed to be only only left lateralized. So this is if you split the neuroimaging studies that I showed you into smaller parts. Then, actually, Zhang-Hao did this fantastic work about trying to get whatever Penfield in his 20, 30, 40 years of neurostimulation literature did. And he kind of plotted it on this mesh in the surface. And actually, what we call exogenous imagery, meaning imagery due to stimulation, actually seems to be more right lateralized, or to say, if you stimulate the right inferior temporal lobe, you will have a participant report the feeling of imagining or of seeing people with scenes or object. So somehow endogenous, please, Leah, imagine Mona Lisa, versus exogenous, Leah, give me your brain, I'm gonna stimulate it. This shows slightly different pattern, right? So with endogenous, more left lateralized, or somehow bilateral regions, while right being more right lateralized. So this is what we came up with. Again, we are trying to reconcile the literature, and we observed that while for faces, for example, both neuropsychological, neuroimaging, and neurostimulation literature seems to have an agreement that, this is a very right hemispheric lateralization of imagery for faces. For words, this seems to be more left lateralized. And of course, we have some areas in between, right? Some stimuli that are more in between. And also we can observe the lack of some complete lack of data on some fields. For example, ordinal time has been studied only using neuroimaging and not using neurostimulation and so on. This is just to show you that if you're attending this talk and you're interested in mental imagery, there's a lot of things that still needs to be done. All right, so patch it together, neuroimaging data with neurostimulation data with animal stuff. So we know from Zhao's work that we can record from the primate brain neuronal populations in the inferior temporal lobe, inferior and medial temporal lobe in the primate brain, exactly in the macaque, and still observe phase related activation. So again, trying to, even though superficially, of course, trying to tie these things together and see right versus left lateralization of stimuli, and that this function, mental imagery, initially thought as very much, very high level, it's instead also shared with other species. I'm going to conclude in a few minutes, but I want to make sure that we are on the same page here. Do you have any question? I saw some activity in the chat, but I cannot click because of Zoom is terrible. All right. Okay. So the third thing is, let's recap. We have a model, it has a problem, we can do better. How can we do better? Let's look at the literature cohesively in neuropsychological, neuroimaging, and simulation, and we can observe what happened actually in the world out there. And we see that there's a few recurring patterns, including this left inferior temporal region. So I'm going to just shoot out there a new model of mental imagery, which is simplistic, but it's better, or at least it fits better the data we have than what it's in your cognitive neuroscience textbook right now. So we said that to imagine something, Lauren needed to have that image in the long-term memory. Mona Lisa in your MTL, somewhere in your MTL. But this is not purely memory. I'm not asking you to recall something. I'm asking you to imagine something. And memory and imagery cannot be overlapping. So we need an interface that allows you to pictorially add features to Mona Lisa, not Mona Lisa as the stored memory, but Mona Lisa as the image of Mona Lisa, the apple, imagine a red apple, imagine a stimulus. So we need a node somewhere in the, maybe biologically speaking, it makes sense that it's very close to the MTL. We need a node to kind of picture, draw around this information that Lauren had about her Mona Lisa. And then we said that Victor needed a mechanism for maintaining and exploring this Mona Lisa. Hair, curved, straight, hands, we're looking at you. And we observed that frontoparietal network, singular peripheral network, this is what they do. They make you focus and sustain an image or a stimulus or information over time to use it. My phone number is 1, 2, 3, 4, 5, 6, 7, 8. You can remember that number also in an hour because it's simple, but because you have a mechanism that allows you to recall that. So the FIN, and the frontoparietal network. And the third thing is let's piece it together. So maybe a more biologically plausible model is a model that joins the frontoparietal attention network with these areas in the inferior and medial temporal lobe for storing and recalling information. Why is it important to study mental imagery? Because societally speaking, also we know that we are we are covered ourselves, bathed into biases that we are not aware of, stereotypes and prejudices and racial biases. And here in the United States, we see it a lot. And we know that mental images must have a role in forming stereotypes. What is a stereotype if not a simplified, crystallized mental image? And it's not that we know it because I'm saying it, and that's the microphone, but because we also know, and this is a completely different field that has been going on by itself forever, we know that imagining positive intergroup contact, imagining, has the ability to reduce negative stereotyping and prejudice towards a variety of outgroup identities. And this is social psychology literature. This is what they do. When you want to reduce the bias towards a category, the black man, it's okay, it works, effectively works, to imagine having intergroup contact with that category. So there is a link there, and this link has been also reviewed by Ben Eisenstadt, who is working with me right now on this. But mental imagery is so important because it opens a door towards more social aspect of bias, stereotypic, prejudice, and so on. And this is not because I'm saying it, but because social psychology is saying it. Okay, acknowledgement, very quickly, I want to acknowledge everybody that's been working with me. This is absolutely not possible to do without people and so many others of you. And this is some info about myself if you want to check it out. And I hope you enjoyed it, and I hope it was interesting, and I hope we together learned what it takes to imagine something, at least a little bit more. And thank you so much.
Thank you so much for this interesting talk. I found it very clear, very concise, very easy to follow. So I'm going to start with questions. If anyone has general questions about what was presented or just questions more generally, feel free to raise your hand if you're on Zoom, and I can pass you the floor and you can ask it yourself. Otherwise, if you feel more comfortable not asking it, you could definitely write it in the chat box, which I can read the question for you. Otherwise, if you're on YouTube, please feel free to write the question in the comment section, and the question will be relayed to me and I will ask the question for you. So please feel free. Yes, go ahead, Peter.
Hey, thank you again, Professor. Wonderful, as always. I had a couple of comments. The second one is going to ultimately appear as a question. The first comment was about the mental imagery task at the beginning, imagining the Mona Lisa. And I was really struck and surprised that I've interacted with that image so many times, but I had no recollection at all and would have bet money that it didn't have that she didn't have a torso. I remembered the Mona Lisa as just being a head and looking a little off to the side. So I was shocked when the picture came up and there were her beautiful hands and her dress and the whole thing. So that was really interesting to me too, that there was an inadvertent stereotype or condition that was crystallized in my mind about that picture. But the other thing that came to mind is, and you touched on it briefly, about audition versus vision as well. And I recalled the study that we analyzed last fall by Stephanie Martin about the music performance and how the performance of a piano piece through an electronic keyboard, while the piano player could hear the music, activated X number of areas in the auditory cortex. Yet when the sound was turned off and he was simply doing it from memory, imagining the sound, it activated almost exactly the same areas. And I thought that was really curious. But as you kept talking, I thought, well, perhaps the condition was different because the person was going through the motions of that sound. So I wondered if it was maybe more motor related, motor perception than just audition. So kind of a question, but just a thought that popped in my mind.
Right. What you're talking about is in the article from Stephanie Martin and from Bob Knight's group and so on, which is a very interesting article. So we should discuss offline this just because it has a lot of consequence. What you're saying is very important. But what I will remind everyone there is that these authors compared playing the piano, so listening to the music as you play, versus playing the piano with the sound off. So the only difference that was happening is that the person was playing but couldn't hear any stimulus, right? As if you put the headphones away, right? But you keep playing. And therefore they tested mental imagery, auditory mental imagery in that study. And just to remember, one of the conclusions that we're getting, there was no primary auditory cortex activation associated with imagery, auditory imagery. So again, if you study realms or modalities that are beyond the visual one, you don't see primary cortex activated the same way we don't see it in visual, but also in motor cortex. Motor imagery does not activate M1 in humans. The olfactory does, if there is a O1, people still debate about it, but I want to throw a little idea to everyone. So, and thank you so much, Peter, for reminding me about this. The thing is, if we really had V1 activated every time we imagine something, how could we distinguish between reality and imagination if the process is identical, if the regions are overlapping 100%, if it's just a matter of a reverse hierarchy? What do we get? We have a feeling of the reverse hierarchy. So because it's starting from frontal, it's imagination. I don't think that's the case. I think that what we see is that you don't want to have your primary cortex activated when you're imagining something, because if you do, then you're hallucinating all the time. Then you are in the post-traumatic stress disorder, schizophrenia realm, in which the detail of that image is so strong that you confuse reality with imagination. Right? So I think that even if I know it's superficial what I'm trying to say, but I think that biologically it makes sense that you want to spare something. You want to make a difference between perception and imagery. And maybe it's just V1, A1, O1, M1 that you're taking out of the process so that you can, or you're still able to discern between I'm imagining something or I'm perceiving something. I think it would make sense. I would build a brain that way.
Thank you very much. I actually had a question. I know that you mentioned that the long-term memory is involved, but in terms of blind people, do blind people have mental imagery? And is it any different from what people who can see? Is it any different from those who have the ability to see, I guess is the question.
That is a great question. And it depends if we're talking about congenital blindness or acquired blindness, right? Because if you saw Mona Lisa and you lost your sight, you can still imagine it. But, and I don't remember a lot about the literature, I'm not 100% sure, but it seems like congenitally blind individuals that met with a stimulus through auditory information, right? For example, the apple is a round object and round looks like this. So explaining more, there was a long debate in imagery about pictorial versus descriptive imagery. Does it come in images or in words, right? They still can imagine that item. They imagine it with the features that they learned with, I don't know how to say, but like they imagine it as, okay, it's a round object, whatever that means. They also, congenitally blind people can imagine, but can imagine whatever they know of that stimulus.
And I guess an interesting question that I would have, just to bounce off of that one, in terms, has there been any studies to your knowledge in terms of the activation in the brain on congenitally blind people, so people who have been blind from birth? Have there been studies on, is it the same activation as those with the ability to see?
That's a good question. I think that there's an article, and Paolo, maybe you can pitch in on this. There's an article from Laurent Cohen lately about the activation of visual cortex in blind individuals. I don't remember 100% what was the finding. So if you can stop recording and cut that part of
yes, the idea is for congenital blind individuals, they do use their visual cortex, but for other things, of course, not for vision. They use it for syntax, for working memory, so perhaps also for some kind of mental imagery. But there is a bunch of studies now. I don't remember the details, but there is Cesare Cornoldi in Italy who has been studying this congenital blind subjects. On the other hand, for acquired blindness, there is an interesting patient described by Georg Goldenberg, she had cortical blindness after bilateral damage to the early visual cortex. And like some of these patients, she had anosognosia for her deficit. So she was convinced that she could see, even if she was completely blind. This is called Anton syndrome, anosognosia for cortical blindness. And she had a particularly vivid visual mental imagery. And so the idea of Georg Goldenberg's was that actually it was her mental imagery which sustained the illusion of seeing in this patient. But once again, she had V1 lesions, bilateral V1 lesions, and perfect visual mental imagery. So perfectly consistent with the points that Alfredo was making today.
Yes, Leah, please go ahead. And then Victor.
Okay, so thank you very much for the talk. So the first time I've heard about imagery was for rehabilitation purpose. There was this patient who had a hand transplantation. And so for rehabilitation, for using his hand, the process was imaging like grasping these things, and they acquired FMRI both with imagery and this hand grasping, and the area activated were really overlapping. So for me, it was really surprising this like rehabilitation path that imaginary can have. And as you've shown, like there is this overlap between the activation. It just seems missing the occipital part. So I want to ask you, what do you think about this potential use of imaginary?
Oh, that's fantastic. One thing that I'm really trying to work on, and I've started with a few students, is I think that imagery has so many potential in the rehab field. In particular, I'm talking about visual imagery, but of course that's true for motor cortex. So think about, there's an article that we started writing that is called, it's a very pretentious title, I have to admit, which is called Visual Mental Imagery, the potential for a universal approach to blindness. Because if we were just able, right now, if you are blind, depending on at which level in the visual pathway you have a problem, let's say, it can be retinal, chias, MEL-GN, and so on. Surgical intervention will try to poke in that specific area, right? So if you have a retinal degeneration, we create a retinal surface that will replace the back of your retina, right? So we're replacing that. If you have a problem in the LGN, if you have a problem in B1. But how about we stimulate the fusiform gyrus, the FIM, which gives you the feeling of seeing a face, and the stimulation matches exactly what's out there through a camera, and therefore we go and stimulate neuron. It's a very futuristic view, but why don't we interface with these areas that give you the feeling of imagining the face of your grandma, and we stimulate with a like we do with the auditory system, right? Getting an implant, bypassing the cochlea and going directly into your auditory cortex and try to stimulate those neurons. Why don't we do it with the imagery and therefore with motor system? Because we can give the feeling and somehow the ability back to people in this way, up to a certain point, but absolutely. I don't know if I've answered your point. Or if it
yes, sorry. Indeed, my example was for motor imagery, not visual imaging. But yes, the perspective that you mentioned is really interesting also in this field.
Why are we focusing on right now? Cortical implants for vision restoration are focused on V1, making exactly the same mistake we're talking about right now. Because if you stimulate V1, you get spots and little lights. And that's what they find in the article. Oh, this cortical implant didn't really restore vision. They just gave back some, but that's what V1 does. Why are you expecting that stimulating V1 will give you a more complex percept than what V1 does? Blobs, colors, lines, why instead don't we move forward in the ventral stream so that we can actually stimulate more complex percepts? And the same thing is for motor system. Absolutely, we can use this stuff. Yes.
Thank you.
I'm super excited about this project. So, that's why I'm talking a lot. Victor.
Right, thank you for the great talk. I was just wondering about if you had any opinion about using resting state fMRI to study this kind of thing, because resting state, I think, is probably one of the paradigm in fMRI where the subject might actually use a lot of this mental imaging even without even being prompted. So I was thinking maybe it could be used for studying this kind of thing, but I have no knowledge of it. So I just wanted to ask you if you know about it, if there was something about in this field.
Right. So your question is great, and it's actually it's actually problematic with mental imagery because of one reason. But there is all this field of consciousness neuroscience that is going on with no report paradigm, right? So let's put that on the side 1 second. So the problem with mental imagery, and this has affected a lot, especially early studies, is that the way they worked was, Victor, imagine an apple, and when you are done, press the button. What happened in that paradigm is that we don't know whether you did it, how much you did it. We don't know anything about what happened. We just know that you pressed the button. We don't know when your imagery started, when it ended, how vivid it was, and so on. So to overcome this problem of imagery so inner that we have no idea what's going on, I'm not presenting anything to you, so there's no stimulus that I can control, it's all in your brain. Then recent literature moved towards more a, let's ask you to do something. For example, there's a clock, the mental clock task, right? There's a clock, the two hands of the clock are pointing at 4 p.m., another clock at 6 p.m., compare the two and tell me which one has the greatest angle, right? And give me a response. 6 p.m., the two hands are vertical, so the angle is very big. 4 p.m., the angle is smaller, right? So your response would be 6 p.m. This gives us an accuracy measure, and therefore gives us the ability to say, okay, Victor did the task actually in that condition, supposedly, or he was lucky. But somehow it gives us the opportunity to measure accuracy again. So to know when very likely you did the instruction, you did the task that we asked you to do. When we are completely blind, like in resting state, we don't know what's going on. Definitely you are using your mental imagery, resting state. If you have been in fMRI scanner during resting state, you have thought all sorts of things, including your grocery list, you're hungry, you just want to leave, this thing is too noisy. So you think all these things for sure. So there's imagery, but we don't have a trigger to talk more fMRI stuff. You don't have a trigger to pinpoint when that thing started and ended. So it's very difficult to extract it as a pure measure of mental imagery, which is exactly what happened in the beginning of mental imagery itself. Victor, imagine an apple. I don't know if you are right now. I can only trust you. And I don't know when it started, not where it ended, but I know your button press. So it's, it's difficult. There's no monitor. I'm not playing anything, right? So it's very difficult. But that's a good point.
All right, thank you. Yes, because I was thinking, when you were talking, I was thinking, yeah, there's no way to know exactly how much different people will imagine this kind of thing. But the only way that we could use it would be to compare people with normal brain and people that cannot have this kind of imaging, mental imaging. But yeah, that I think it may be too much of a pain compared to other paradigms. So yeah, okay, thank you.
Thank you, Victor. And if I have an extra minute, Stephanie and Lauren, I'm going to check it. Can I add a little thing? So just to remind what I said earlier, which is in the consciousness field, there's a lot of people that are using this no report paradigm. So in order to exclude all the motor component and so on from the data that they are collecting, they're asking participants to perform visual conscious perception stuff without having participants do anything, right? And that's a very powerful method, and it's actually being used. And Laura Tremblay, who's here, has been reading this literature a lot. It's what is being used in imagery of, for example, rodents, in which you can, without having the rodent move in the maze, you can predict where the rodent wants to go. So imagining where the food, where the reward is, just by looking at the brain activity. So somehow you can predict that the rodent will go right or left because a set of neurons actually activated compared to the other one. So in a no report kind of way, without the rodent actually, the mouse actually going in that direction. So definitely, Victor, there's something that we could be doing in that sense. There's some sort of task that we can come up with in more of a resting state kind of, or no report imagery. But we need you to come up with it, and we will sponsor it.
Okay, well, thank you so much, Dr. Spagna, for this really awesome talk. It was very clear, very engaging. This is the plug for our next talk, which will be on the 27th of May at 4 p.m. Paris time, where Dr. Morten L. Kringelbach will be talking about the neuroscience of hedonia and eudaimonia. Please feel free to join us. Also follow us. Check out our website for the new content. Also, we're going to be launching a brief poll in the next 2 minutes, just to find out where everyone is based and to get some sort of statistics on you guys. And also, if you're free for the next couple minutes, feel free to hang around and we can have an informal chat without the live stream. So thank you all for joining us. Thank you very much, Dr. Spagna, and I'll see you next month.
Thank you.